Uh, Hello everyone, my name is Rila Dinesh from CSIDA section. Uh, in design and analysis of algorithms, my tech talk concept is dynamic hash table. Let's see the introduction now. Sorry. Let's see the introduction. Introduction to dynamic hash tables. Dynamic hash tables are data structures that allows efficient insertion, deletion, and uh, and retrieval of key value pair. Okay. They dynamic adjust their size to the accommodate varying amount of data, providing flexibility and optimal performance. Dynamic hash table use hashing function to map keys to efficient location within the table, enable quick access to store data. Normally, dynamic hash table is used to store data which uh, by using the dynamic hash table, we can retrieve, insert, and delete the data easily, and we can if the dynamic hash table is more efficient to retrieve the data, we can access speedily. And for this dynamic hashing table, we use the key value pair concept were mapped by this hash function. Here we have here we have keys are gems alien hash function which used to map here storage by using this 0001. These are the addresses. By using this, the hash function will maps and retrieve the data, related data, which is stored in storage. Okay. Now we'll see the advantages of dynamic hash table. Dynamic hash table offer constant time complexity for key operation such as insertion, deletion, and searches. They can efficiently handle large data sets by dynamically resizing and distributing elements. Dynamic hash table provides balance between space utilization and performance, making them suitable for a wide range of application. Wide range of application. As I told before, for retrieving, for delete, for searching, deleting, inserting, the time complexity is constant, means big of one. Such as the we having different storing, we use tags, hash, they all have a big of n. But here we have the constant time. Yeah, it is the main advantage is the dynamic hash table is the time complexity, that is one. Here, this mapping here, that function, hash function is nothing but indexes. Is 01. This indexes, this John Smith contains the index of 872. 872 mapped by this John Smith, where the key value pair, while key is found, then the value also found. We can retrieve we having the balance, space utilization, and performance. Now we can see the hash function in dynamic hash table. Hash functions plays a crucial role in dynamic hash table by converting key into unique indexes within the table. A, a good hash function minimizes the collisions where the multiple keys map to same location, which are the efficient data retrieval. Dynamic hash table often use the techniques like chaining or opening addressing to handle the collisions and maintaining the data integrity. Normally, collision is nothing but if the key, I will show it. If the key has the same indexes, if the any key has the same indexes, then the collision occurs. Because if the keys have same indexes, then then system does not know which data must be retrieved because they're having same indexes. To overcome this drawback, the dynamic hash collision. uh, to overcome this drawback of collision, we having the three. One of the technique is open addressing. Now, dynamic resizing in hash table. Dynamic hash table resize themselves when the number of elements exceed a predefined load factor threshold. Resizing involves creating a new large table, rehashing existing elements and referring them to a new table. Dynamic resizing ensures that table remains efficient in terms of space usage and access time as data grows or sinks. Here we having C. Here the key value. Key is a Patrick. Where is the key is a 1, 2, 3. Value is a Patrick. Then here key dot hash code. Here they having the hashing codes here. Then we having this is a we can say this is a dynamic resizing technique. It is a one of the resizing collision. To avoid the collision, it is a one of a dynamic resizing is a one of a technique to avoid the collisions. One is open addressing. Open addressing in nothing but if any indexes are same, then if the next index is empty, then this same index will be copied into the next index. That's it. Load factor in dynamic hash table. Load factor of dynamic hash table is the ratio, the number of elements to the total number of slots in the table. The high load factor can lead in increasing the collision degree performance, prompting the table to resize. By adjusting the load factor threshold, the developer can control the frequency of resizing operation to optimize performance. This load factor is nothing but keys. Number of keys will increase the load. See here, the total number of slots in the table. The high load factor can lead in increasing the collision. That's it. If the n number of keys, then the load also increases. Here we can see the buckets. Here storage also called as buckets. These are the index and these are the keys. Here you can see that. Here you can see that Sandra D and John Smith has the same indexes 152, 152. And then John Smith and Sandra Day are put into the see 1 to 152 and 153 is empty. That's why the standard D is kept here. This is called this technique is a open chain method, open addressing. Sorry, collision resolution strategies. Dynamic hash table. Here we have that dynamic hash table employ various collision resolution strategies to handle situations where multi-key maps to same locations. Chaining involves storing multiple key value pairs to the same indexes, typically using the linked list or array. As I told in previous slide, what is a collision? Collision occurs when there is a number of indexes, when there is a number of keys having the same indexes such that the system cannot know which data must be provided to the user, such that to avoid that type of drawback is called as a collision. To avoid that collision, to avoid this drawback, the collision resolving techniques are there. First one is chaining, second one is open addressing, and third one is a dynamic hashing table. Dynamic hashing table has then in previous slide, now we will see the performance considering in dynamic hash table. Now we will see about the performance. The performance of dynamic hash table is influenced by the factors such as the quality of the hash function, load factor, and collision resolution strategies. Efficient resizing the mechanism and appropriate load factor management are critical for maintaining optical performance. Careful selection of a function and collision resolution techniques can significantly impact the overall efficiency of a dynamic hash table. Use cases of dynamic hash table. Dynamic hash table are commonly used in applications that require fast access to key value pairs such as database catching system and in memory data structures. They are suitable for scenarios where the size of a data set is unpredictable and may vary over time. Dynamic hash table also utilized in routing algorithm symbol tables, and various indexes mechanism for efficient data retrievals. Scalability and flexibility of a dynamic hash table. Dynamic hash table offers a scalability and dynamic adjustment. Their size accommodate changing the data volume without sacrificing the performance. They provide flexibility in managing the key value pair efficient, making them versatile for a wide range of applications. With proper design and tuning, dynamic hashing table can handle massive data set while ensuring the quick access time and minimal memory overhead. Now we will see the challenges and consideration in dynamic hash table. Designing efficient hashing table and collision resolution strategies are required careful consider to avoid the performance bottlenecks. Balancing space utilization with access time can be changing, especially in scenarios with highly dynamic table. Proper tuning of loading factor thresholds, the resizing policies is essential to maintain the desired trade-offs between the space efficient and performance. Comparison with a static hashing table. Dynamic Dynamic hash table offers the advantage of adaptability and efficient resizing capability. Compared to static hashing table with fixed size, static hash table may suffer from wasted space or performance degradations when the number of elements varies significantly. Dynamic hash table provides a memory dynamic and responsive solution for managing key value pair in scenarios with a unpredictable data size. Now we'll see the real world examples of dynamic hash table. Popular programming languages like Python, Java offer build the support for dynamic hash tables through the data structures such as the dictionaries and hash maps. NoSQL database like MongoDB and Redis use this use the dynamic hash table internal for a fast data retrieval and storage. Web servers also. Conclusion. Dynamic hash table are versatile data structures that offer efficient key value pair manages with the dynamic resizing compatibility. Understanding the principles and best practices of dynamic hash table is essential for developing high performance application that require fast data retrieval and manipulation by using hash functions, collision resolution strategies, and proper load factor management. Dynamic hash table provides a fast access time and space efficient storage. These are the some questions. Thank you and have a nice day.